Well, here we are, part 8 of my Ender 5 upgrade series, and in this video I'm finally going to be tackling something I've been meaning to do for quite some time on my Ender 5, and that is balancing and improving the cooling of the Ender 5 printer. What's great about this video is going to be that it not only applies to the Ender 5, but the same hot end and cooling assembly that you see on the Ender 5 is shared with a lot of the other Creality printers. That means that the Ender 3, the CR10 can all benefit from this video and from what I'm going to share about why we're actually going to make this modification, what the purpose is, and what we're actually going to be looking for. That's what we're doing right here today on Kersey Fabrications. Let's go. So to get the ball rolling, let's talk about why cooling is important on any 3D printer. So looking at the Ender 5 cooling assembly, and like I said, this is shared with a lot of other Creality printers, you'll see that there are two fans. One, there's a 40mm fan that is used to cool the heat sink that you'll find on the hot end. So what that does is it makes sure that you're not getting what's called heat creep up into that heat sink, which would cause your filament to melt prematurely. The second part, and what we're actually looking at in this video, is what's called the part cooling fan. The part cooling fan is actually used, just as it sounds, to cool the part that you're printing. So certain types of thermoplastics, like PLA, need to be cooled quickly once they've been extruded out of the nozzle. And what that does is it solidifies them. It makes sure that, number one, they hold their shape, and number two, that they're ready to receive the next layer of filament when it goes up to the next level. So proper part cooling does three things for us, really. Number one, it ensures that there's no cooling artifacts on the actual print. It makes sure that you don't see any drooping extrusions or any rough extrusions on the edges. Number two, good cooling can actually make sure that you don't need additional supports on your print. That means less removing of supports when you're done, and also potentially a better quality print because you're not going to have the support removal artifacts after you cut those off. Number three, and most importantly, is it's going to reduce the number of printing failures. So you may have seen before, if you ever have improper cooling on a really steep angle in particular, you may see that that print actually starts to curl up, or that it begins to get a little rough on top. What that can do is it can actually catch your nozzle, and when it catches your nozzle, one of two things is going to happen. Number one, it may knock your part off your printer, which of course means a failure, it means starting over. Or number two, it actually may catch that nozzle, causing one of your motors to slip, and then you have what's called a layer shift. And because of that layer shift, again, you're going to start extruding plastic where it's not meant to be, and you're going to have to start over. So a lot of those questions and concerns could be due to improper cooling or the printer not being able to lay down layers correctly and thus producing a print failure. Now let's turn to the Creality printer specifically, or any printer that shares a similar design to this stock cooler from Creality. So as I mentioned, this 40mm fan is specifically designed to cool the hot end, or the heat sink that separates the hot end from the cold end. Well, that same fan does blow a little bit onto the part due to the design of this and there not being anywhere for the airflow to go, so it goes down onto the part. But that's not the primary cooling for the part, that's just extra. The other fan, the blower on the side, is the one that is primarily designed to cool the part. Now, one of the problems with this design is there's only a fan on one side. Now, under most situations, most prints that you're going to find, that's probably good enough. And in my testing, I found that it's probably good enough. Now, but where you're going to have problems is if you have an extreme angle or an extreme overhang on your print. So, for example, this Iron Man gauntlet that I was printing, it has overhangs on both sides. It has one on this side of the gauntlet, as well as this side of the gauntlet. And so, one side, the side with the cooling, is very clean. The overhangs look very good. The corners look very clean. There's not going to be any cleanup I have to do there. I can just do any normal sanding or filling that I'm going to do. While on the other side, the corners are very rough where there's that overhang. And that's because there wasn't direct cooling on that edge. It was trying to get around with this cooler, but it couldn't get to it because there was other plastic in the way. So this is a situation you may find on some models. Now, if you know about this issue, a lot of the times you can orient the model to where the overhangs are specifically facing the cooler, but you're not always going to have that ability on your printer to twist it around, particularly if you're working with a shape that has overhangs on more than 2 or 3 different sides of the print. So, why did I decide to tackle this now? Well, if you follow me on other social media, you may have seen me printing this model from Nikko Industries. What this is an Iron Man model. It says, "I love you 3000" on the bottom. It has Iron Man hugging his daughter in the pose that he's in at the end of Endgame. Well, all of the bottom pieces were pieces that oriented well on my print bed, and I could pretty much guarantee that the cooling would not be a problem. But I was really concerned with the top part that has a lot of overhangs. There are arms, there are legs, there's the daughter's skirt. This was an important model to me. I really didn't want the model to get messed up due to improper cooling, or me have to put extra supports on this model, and then there'll be more cleanup. So this was the ideal time for me to go ahead and tackle cooling. So what was I looking for in my cooler? Well, first of all, I wanted to mine the market that's already there. I know that there are a lot of Creality printers out there. I know that there are a lot of people that have already tackled this problem. So I didn't really want to invent the wheel and try to create my own if there were perfectly good models out there. I went to Thingiverse, usually the first place to go, and I found several models that fit the bill. And I actually went on sort of a journey where I was trying to do the least modification to the printer as possible. So the first model I found is called an AS Hero V2S. Now what I really liked about this model is that it did not require any modding of the actual fans themselves. This mod actually attempts to use the existing fans that come with the printer and just create a new design, new layout for this, which also gives us the dual cooling for both sides of the printer. It was also a really nice model in terms of the amount of supports I had. It was minimal. It didn't require me even actually removing the heatsink from the mounting plate. I would just remove the existing mount for the fans and all, and then just attach them to here. I'd be ready to go. The next part I found was by a designer called Zvox, and this is simply called the Ender 235 part cooling fan duct. Now this one actually requires you to remove the existing fans that come with the printer, or at least the blower that comes on the printer, and replace it with the 50mm blower. So this one requires a little bit more work, but I knew I was going to have to do that to evaluate more than one mod and share them all with you. So for the next one, I didn't find it on Thingiverse. This one is called the BantaMount, and what's really nice about this, just like the next one I'm going to show you, is that it is a modular mounting system. So this mounts directly to the plate, and then you can choose which type of cooler you want on it. So a single blower unit, a dual blower unit, or you can actually use a dual radial fan on here as well, but I'm not going to be evaluating that today. And finally, I'm going to be taking a look at a mod called the Hero Me Gen3, which they say is for the CR10, the Ender 3, the Ender 5, Ender 3 Pro. Again, it's for all Creality printers. This one is the one that's still on the printer as of right now. And much like the BantaMount, this is a modular mounting system that has a mount that goes on the plate, and then you can change out the cooling solution. So again, there's a single 50mm blower solution, a dual 50mm blower solution, as well as some others. One thing to keep in mind as I go through this entire review, please note that number one, this is not a scientific exploration of cooling. I'm not evaluating the airflow of any of these. I'm evaluating this from a very practical perspective. I found some coolers, I printed them out. I'm going to see how they actually affect the part cooling on this printer. The other thing to note is that some of these coolers can come in different configurations. I tried to choose the ones that I thought would provide the best cooling, and we're also going to take a look a little bit at the volume that you're going to expect from the cooling solutions, meaning how loud are the fans when you put them on here. So let's talk about the test that I'm going to perform on each of these coolers, including the stock. So one thing I wanted to do was to take an overhang test put them side by side, which allows us to see how the overhangs respond on both sides of the hot end. You're going to see the left and the right. I'm going to do my best to explain which one I'm talking about, but I realize that the orientation of either your printer or me on camera may be a little confusing, so I'll try to refer to it as the cooling side or the non-cooled side if we're only dealing with the one-sided cooling. So this dual overhang test has angles all the way up and down, starting at 55 degrees, going all the way up to 85 degrees. And what that will allow me to do is, for the graphs that you're going to see me generate, I'm going to round to a 5-degree increment, which is about as close as I can get here. I'm going to use that angle to plug into my slicer when it's time to actually choose what the maximum overhang is. So 5 degrees actually works really well. If that goes well, if I'm happy with that, or more specifically, if it does better than the stock cooler, I'm then going to do a bridge test. And that bridge test will let me know how much sagging I see on really long bridges. Bridges are important with printing because, again, it reduces the amount of supports that you need. And it also really demonstrates how well the cooling is doing, because if it can go such a long distance, it's probably cooling fairly well as it's coming out of the nozzle. And then what I did, I came up with two metrics. One, I wanted to see where do I consider the print to still be really good, so I'm happy with the quality still. And then two, where did I see it finally fail? Meaning, where was I not seeing it cool sufficiently enough to where I would even consider that a print I would want to continue? So on the stock cooler, what I saw was, on the good, I was happy with the print. On the left side, meaning the uncooled side, was at the 60-degree mark. On the right side at the 70-degree mark. And then on the failure case, they started to both fail about at the 85-degree mark. That was about as far as I could push it before it really started to droop down. And then, since this is the control, this is where we're starting at, I did do the bridge test. For this bridge test, I didn't see any failed lines, meaning there's nothing that actually drooped down to the point where it was resting on the line below it. There was a little drooping, nothing too bad, but it was definitely not perfect. Again, we're still talking about this cooler being acceptable. I've printed with this cooler, the default cooler, the entire time. So let's move on to the first competitor. This one is the AS Hero V2. Was really happy with this one when I first found it, because I'm like, okay, well, we get the dual printing, meaning the left and the right side printing, as well as not having to overly mod the printer, not actually having to do any electronics work on the printer, which some people may be adverse to. So on this one, again, you pull off the existing fans. The front fan goes here. The side fan actually really fits well on this printer. This is a really well designed mod. But when it came time to actually testing this mod, it didn't turn out to be a very good idea. The good was only up to 55 degrees on both the left and the right. So I can't say, hey, at least we got even cooling, left and the right side looking about the same. Failure was about where we saw it on the stock one, and we started seeing the drooping about 85. You may have been able to call this a little bit before 85, but there wasn't actually technically any severe drooping until the 85-degree mark. So since this one wasn't even quite as good as the stock cooler, I didn't worry about an overhang test, and I moved on to the next one. So this is a good point where I'm going to actually pause and talk about how do you mod this printer? What is the best practice when it comes to removing any of these fans in order to put on new fans? So let me walk you through the process that I went through to remove these fans, add some connectors so that we can swap these out later, particularly if we have a fan failure in the future. So the first thing we're going to do, of course, is remove the existing fan assembly. Then we can remove the two fans from that assembly. Once we get them removed, which is pretty easy, just a few screws, then we can snip these fans off so that we can attach the new fans. Make sure you leave yourself some extra wire in case you want to attach connectors to reuse these fans later. Next up, we're going to make sure we slide on our heat shrink tubing first. Then we can tin these new connector as well as the wires to make the attachment of this connector easy. Then we'll just pull down the heat shrink tubing when we're done, and we'll be ready to move on to the second connector. You'll notice on this connector, as I'm soldering it, I still have the wire hooked up going to my new fan. The reason I do that is so that I can tell the polarity of the new fan so that it won't be switching out connectors later on. And once I have everything soldered on, of course, I pull down my heat shrink tubing. Then I can use my soldering iron to melt that tubing, and I'm ready to go. So now that we've done the wiring mod, you can now use whichever fans you want on there. So this allows us to move on to our next cooler, the ZVOX cooler. Now the ZVOX cooler, you can use the same 40mm fan for the heatsink cooling. The heatsink will slide directly in the top of this, and keep in mind that's going to limit the heat sinks you can use because they're going to have to be exactly the same size as the original one. It does slide in well though. And then you can use a 50mm blower to actually provide the part cooling. And then it has this nice channel which hopefully will evenly distribute the cooling around your part. So let's find out how this one actually does in practical part cooling. So looking at the actual overhang test with this one, we see again the left, right cooling about the same. We're not seeing any big difference between the left and the right cooling. This one's working slightly better than the Hero V2S was. In fact, we're getting up to the 60-degree mark on here, and failures again at 85. So again though, this one's still not really working up to par to even the stock cooler, because on the right we were still getting better cooling than we were the left. So again, on this one I didn't run the bridge test because we're still not even up to the level of the stock cooler. So let's move on to the third mod, which is the BantaMount. So first of all, I was really happy when I saw the BantaMount. It has a very clean website, a nice place to download it. The guy has spent a lot of time on actually delivering the parts to you, the end user. So you go onto the website, you will actually select the parts that you want, sign up for an account, and then he will send you the files via email. So the way this works, it starts with a base mount that you'll get for your plate, and then you can choose whichever cooling options you want, whether you want a radial fan, meaning the type that has the motor in the center, or whether you want a blower fan. So with this one, I did download the Ender 5 mount specifically. I found the Ender 5 mount did not go on the way that I would want it to, but it actually wasn't a big deal. I was able to cut off the back mount, smooth that out, and then since you actually do have to pull off the heatsink to mount this one, I actually was able to use the through holes, use longer screws, and actually mount those holes all the way into the mounting plate, which actually secured this really well, which was different than the original designer had planned, but it worked really well for me without any real heavy modification of the printer to install this. Once your mounting plate is on there, then you can easily switch back and forth between the different cooling options just by removing 2 screws and putting your fan on top. So with this one, I first started with the single fan solution. So with the single fan solution, what we saw was it was a bit uneven, much like what we saw with the original cooler, the stock cooler that we were working with, but it was actually the opposite direction, meaning we saw better cooling on the left, slightly worse cooling on the right. Overall, I was happy with the results, but it wasn't a great improvement over the stock cooler. Again, we were left with failures at 85 degrees, so we were about on par with what I think we saw with the original cooler. Now, moving to the dual fan solution, I was able to run the fans at 100%. Now, keep in mind, when you put 2 blowers on this printer, you're going to have a lot of noise. You also are going to add some vibration to the printer, which is definitely not what you're looking to do. But let's start out with the 100% fan speed. At 100% fan speed, we saw consistent cooling on both sides. I was able to get a 70-degree overhang on both the left and the right, and failure is not until 80 or 85, depending on which side we're talking about. But that 70-degree failure mark, again, that was an improvement over the stock cooler because, again, the right was at 70, but the left was always at 60. So now we have balanced cooling, but unfortunately at the sacrifice for a lot more noise. So in the interest of seeing, hey, can we use this, but maybe just decrease the fan speed, I took the fan speed down to 80%. So at 80%, we had consistent cooling again, but our overhangs dropped 10 degrees to what I thought was acceptable, to 60 degrees. Again, so at 80%, what I was seeing was, again, we had worse cooling performance than the stock cooler. And taking a look at these two, what's important to notice is that the cooling was actually so poor that what I actually saw was a print failure for both of these. These actually knocked off the print bed due to curling at the edges of these overhangs. So taking it down to the 80% mark definitely wasn't going to do the job. But back up to the 100% mark, I actually did do my bridging test, and on the bridging test, I saw, comparing to the stock cooler, the drooping was slightly less, but I actually did have maybe 2 or 3 failures on the bridges, meaning I actually have loose filament here that didn't quite make the bridge. So is this on par with the stock? Probably so, but again, if you compare it to the stock cooler, now what we've done is we've sacrificed slightly better cooling for a lot more noise. So for our final cooler, I went to a part that's found on Thingiverse again, called the Me Gen3. Now, before I go any further with this one, I have to let you know what a pain this cooler was to install. And what I mean by that, as you'll see here in the video, is that I ended up having to remove pretty much the entire mounting bracket to get this one on correctly. Remove the mounting bracket from my rail system. I don't think that would have been any different if I was running the stock rails or the stock wheels. But when I pulled it off, then I could finally get to all the screws and everything I needed to actually mount this. It was kind of nice that the heatsink was still mounted to the mounting bracket, which I actually do like for rigidity. But again, having to remove everything, I guess it's not a big deal if you only have to do this once. I was doing it obviously here 4 or 5 times or more, depending on how much I was going back and forth. But just letting you know, it's a little difficult to print. You'll only want to use supports to the print bed. Do not use supports everywhere, but it does require supports on this one. Once you have everything printed though, once you finally got everything disassembled, you can then put it back together. And as I mentioned on the BantaMount, at that point, then you mount that base plate to it. Then you can swap between which cooling solution you went with. So much like the BantaMount, first I started with a single fan solution, because if a single fan solution will work, you're going to save yourself some noise on your print cooling. So for the single fan results, what I saw is finally able to get up to that magic number I was looking for. And I was able to get up to 70 on the left, 70 on the right for the overhang angle, and I was really happy with that result. Again, failures at the 80 to 85 degree mark, where hopefully you won't be printing, but that's what we saw typically for all the other coolers. So given that the single works so well, I really wanted to see how far we can push this. So I printed the dual cooler solution, which has 2 50mm blowers, and I printed first with 100% fan speed. At 100% fan speed, I was able to get 80 degrees on the left, 75 degrees on the right, and failures on both not until 80. So this is terrific. This is the best I've seen out of any cooler. So I'm like, well, if I can get that out of 100% fan, which again, much like the BantaMount, super loud, way louder than I'd actually want to print at, let's take it down a notch. Let's try 85% on the fan speed. Again, at that point, I still saw really good on the left. I'm not really sure what the huge difference on the left and the right fan were, given that they should be working balanced. But I was able to get the 80 degrees on the left still, the 70 degrees on the right. So I'm still above that 70 degree mark on the right fan. So at that point, I'm curious, hey, well, what if I take it down to 75% on the fan speed? And at that point, I was still getting 70 degrees and 70 degrees on both the left and the right. So kind of what I was getting on the single fan, but with a lot less noise. I would say that The dual fans at 75% was probably quieter than the single fan at 100%. So I was really happy with either result. I could keep the single fan, I could go with the dual fan. But what's nice about the dual fan solution in this particular case is that it gives me some flexibility. If I want more cooling, I can turn up the fan speed. If I want less cooling because the part doesn't require it, I can actually turn it down, which is going to quiet the entire printer at that point. So taking a look at the final analysis of all of these coolers I have laid out here, and the cooler that, as you see, I still have left on my printer, is that the Me Gen3 outperformed all of the other solutions. And doing an analysis of kind of the design of the cooler, I really think what separates the Hero from like the Banta is that it has more airflow. So if you notice on both of the BantaMounts, no matter whether you're dealing with a single or a dual solution, it really goes to a very small nozzle. That nozzle is going to restrict airflow, which is going to limit the amount, particularly if you're trying to push an entire fan through that little nozzle, it's going to limit the amount of air coming out there, limiting the cooling power of the cooler. Whereas the Me actually has more holes and I believe is going to offer a lot more cooling to that part. Not only that, but it actually is a wider opening, which hopefully will cool down more of that surface area of the print. Really think that that is the advantage of the Me Gen3 over the other coolers that I had here on the table. It just cools the part better due to better airflow. So now that I have all of my results, what am I sticking with? As I mentioned, I'm sticking with the Me Gen3. I'm actually going to stick with the dual cooler approach because the dual cooler approach allows me more flexibility. I can go with 100% fan speed if I really need it, but I can also switch over and do 75% if I know the part's not going to need it, making for a much quieter print. So now that I have all that figured out, let's get back to the whole point of all of this, which is producing better, cleaner, nicer prints and getting more performance out of your printer. Let's get back to that Tony Stark statue and let's see what I was able to do, what I was able to print, and let's see this finished up. So here we are with that final piece. I have finally cleaned it all up. This print turned out beautifully. It's important to note, let's talk about the filament real quick. The filament was all done in Filament 1, and both of these filaments, both the silver and this red glint color, this glittery red color, came in my Filament 1 box that I receive every month from them. And it is just a beautiful set of colors for this model. We have the arc reactor here. Again, this model designed by Nikko and his talented artists over at Nikko Industries. We've got the arc reactor here. We have Tony Stark kneeling in his famous pose from Endgame. And I was able to finish this off. You'll notice that there is no degradation in this model on any of the overhangs. I plugged into that 70 degrees. Did not have to worry about any cooling. I think I ran this one at the 85% because I didn't want it to be too loud. You can see all of the detail on this model produced by the Ender 5, the Filament 1, and with help of this cooling mod that I showed you here today. So I hope you found that this video was useful. I hope that not only the examination of the parts on this table was useful, but also my analysis, exactly the test prints I used, and why I went through this process to begin with. I would like to thank all of the designers of these parts, whether that they were the best solution or they didn't provide the best solution. I want them to know that we appreciate their service to the community, and thank you for continuing to design parts that other people can test and use, and I encourage them to continue to work on these parts to improve them. There are going to be a lot of links in the description. There are links to these parts. I've got links to Filament 1 so that you can take a look at their great filaments. Please check out Nikko Industries, who designed this model, as well as a ton of other cosplay models and other statues. I want to thank my patrons that have supported this channel: Alan Reynolds, Asker Vestberg, David Wilson. Thank you very much for your support of this channel. I wanted to do a shout out to you guys because You guys keep this going, and I appreciate your input. Thank you to everyone that comments on these videos. Please tell me what you think about the system that I used to evaluate this. Let me know what you think about the graphs and just the overall process. As always, comment down below what you think my next upgrade should be for the Ender 5s. Believe it or not, I already have 2 or 3 in the pipeline, so there's going to be more here soon. Thanks again. This has been Chris, and you're watching Kersey Fabrications.